Hi everybody, and welcome to the second video on functions. So last time I introduced functions to you, talked about a bit how they're useful, etc., etc. In this video I just want to show you a few more examples of functions so that you get more comfortable with them. So functions are like loops and like lists and things like this, and that it's hard to become comfortable with them after just one day of dealing with them, after just one video. So in this video I'm just going to show you some more slightly more sophisticated examples than last time. So the goal of this video is not to do anything new in particular, but just to give more examples, sort of get our feet more wet with this concept. Okay, so what I want to do is I'm going to give you three examples of functions. And these three examples of functions are all tasks that we've done before. So we're going to do like a factorial calculator, a prime number checker. Okay, these are things we've done before in previous videos, but now I want to separate those tasks out as functions. Okay, so we're not going to do any new code really. We're just going to take code we already had and make it a function task instead of just being in the program itself in the main part. Okay, so let's start with a factorial calculator. So this is something we've done before. Let me just jog your memory on this. If n is a number in factorial, it's just the product of all the numbers less than or equal to n. Right, so 5 factorial, just product all numbers bigger than or equal to 1, smaller than or equal to 5, and you get 120. It's worth noting, by the way, because it might be easier to code in a second, that 5, 4, 3, 2, 1 being 120, that's the same as doing 1 times 2 times 3 times 4 times 5. So the order of multiplication doesn't matter here, because multiplication you can order however you feel like. So 4, 3, 2, 1 will give you the same product of 24 as 1 times 2 times 3 times 4. So what we did in a previous video was write a program that let the user enter a number n, and then you calculate it in factorial. So let's now just write a function that does that and then use it. So let me show you that function over here in the compiler. So define factorial n. So the way the factorial calculator has to work is you have to input a number, and then you have to return the factorial. So let's talk about how this works. You input n, right? Now I have this variable 1 that's going to stand for, it's going to be a stand-in for the factorial of n. And initially, before you do any multiplication, this product is just 1. And then what you need to do is multiply together all n numbers starting at 1, ending at n. And notice this for loop will do that for you. It starts at 1. It does 1 times product, which is just 1. So on the first pass through this loop, you don't change the product at all. So really you could have started here if you felt like, started at 2, but it doesn't matter. Then k clicks up to 2, and now product is 1 times 2, and product becomes 2. Then k clicks up to 3, and now product becomes old product, which is 2 times 3 and gives you 6. Etc. So for each click through k, each new k value, you are just tacking that value of k onto the end of product, and you will stop this process at n. So if n is 6, you will stop at 6. You will not move on to 7. When you're done tacking all these numbers onto product, you will then return it. So let's come down here in main, or outside of the function, and let's just see how this function works, if it's working properly. So I want to print the factorial of, say, 4. Let's see what that does. Okay, so over here in the output box, it prints 24, which is indeed 4 factorial. If I do 5, it does 120. Okay, if I do 6, etc. It seems to be working properly. 720. Okay, so again, what's happening here? This 6 gets fed into this function as n. Okay, so n is just a stand-in, right? It's just a stand-in for any input you want to feed in there. And by the way, you only need one input, right? I mean, you don't need multiple parameters here. To calculate n factorial, you only need to know n. So 6 gets fed in here as n, and then for k in range 1 to 7. So recall the way these for loops work, you actually don't go all the way to the end of this. So if there's a 7 right there, you actually stop at 6. You then do this product thing of 1 times 2 times 3 times 4 times 5 times 6. You then give that product back, which is 720, and that's why down here I can print that. So what's the factorial of 6? Well, it's 720. Okay, so there's an example of a function that uses an idea we've done before, right? Here's a factorial calculating function, right? So the question is, well, why would you use this? And the answer is, well, we're still just sort of getting our feet wet with functions, right? So this still might not seem particularly useful to you, but I can tell you that if you're writing code that deals with probabilities a lot, as I do in my research, a lot of probabilities just come down to counting things, and a lot of times counting things comes down to factorials of things. So that may or not make any sense to you, okay, but just take it on faith. What I'm saying is if you write probability calculating code, you need factorials all over the place, okay? And since you need factorials all over the place, if I didn't have this function, I would just end up writing this same code all over the place. Over and over and over again, I would force the code to write this factorial code, which isn't, I guess, so bad, but it's just really, really inefficient, and I got to copy and paste stuff all over the place, you know? Like, it's just not ideal. On the other hand, if I have this function here, right, then every time I need to calculate a factorial, I just reach up to this function and grab it. So if later in the code I want to print 7 factorial, well, I can just like do that. I don't need to rewrite this code over and over again, right? And then maybe later I need 10 factorial. Oops. You know, whatever, you get the point, right? Every time I need a factorial of something, I just need to figure out what I want factorial of, in this case 10, in this case 7, in this case 6, and I just feed those up into this function. I don't need this, right, this code. I don't need it beneath here, here. You know, I don't need it every time. So again, functions are good for reusability. This is a task that you might need to do like thousands of times inside your code, right? You don't want to write this code thousands of times. Just write it once and then reach up and grab it when you need it. Okay, so there's a factorial function. Let's see what we want to do next. Quiz average calculator, okay? So let's write a function that accepts a list of scores as input, and they can be quiz scores or whatever, it doesn't matter, exam scores. You're just going to feed in a list of scores of something, and calculate the average. So let's see how that might go. Again, we've done this before, so the actual code is not going to be new. Okay, so I'm going to define a function that I'm calling average. You can call it whatever you want. Again, these names, you control the names. You just can't use a reserved word. So like sum, see it's in purple. That's a word that's already reserved for something else. So you can't use a word like while or sum right here. Or sorry, not sum, length. Length is reserved for something else. Or print is reserved for something else. While is already reserved. Okay, so you can't use those words, but other words you can use. So I'm going to define an average function, and for this function to do its job, I have to tell it what I'm going to hand it. In this case, I'm going to hand it a list of scores. And what I need this function to do is calculate the average of the items in that list. So I calculate the average like I've done before. I have the sum variable that initially is 0 because I haven't added anything yet. And then I just traverse my way through this list of scores. So for an individual score in this list, I should tack that score onto the sum, so that when this for loop is done running, I've now just added up all the scores in that list. And if I want to calculate an average, I need to take that sum, divide by the number of scores there were, and that's what length is. Length of scores is just the number of scores. So here's a list of scores down here. I've called it my scores, call it whatever you want. So this person has taken 8 quizzes so far, I guess, and here are their scores. So I can take this list and feed it into this function so that this list of length 8 down here, my scores, gets passed over to this list, right? So this, again, this list scores here, it's just a stand-in. You can pass anything you feel like into here. So now scores and my scores have the same value once you've done this passing here to the function. So you've handed this as input off to the function, and now for score and scores, well, now you're just traversing over this exact list. So the first score is a 10, second score is a 9, third score is a 10, etc. And you're just adding them as you go, and in the end, you will take that sum and divide by length of scores, which in this case is 8. So, and then I print that. I print the average of this list. So this student's doing pretty well, right? That's a A- there, a 91%. Let's say the student bombs the next couple quizzes, right? So now you have a list of length 10. The average, of course, goes down, right? Quite a bit. A couple of zeros are not good for your quiz average. So again, if you're writing a program that just needs averages all the time, right? Average this, average that, average whatever, right? You don't want to just like keep having to write this code over and over again, copying and pasting it around. It's really inefficient. Write this code once, and then when you need it, reach up and grab it. So again, if later in the code, I like have another list of scores. So here's like a second student or something, I don't know, right? And this student's like doing real great. So they're their quiz scores so far, right? If I want to average those scores, I don't need to rewrite that code. I don't need to do this again, right? I can just reach up and grab what's already been done. And, whoop. Oh, sorry, my score is 2 right there, right? So the average of my score is 1 is 73%. The average of my score is 2 is this 98%, right? 9.8 out of 10. Presumably the scores are out of 10. Okay, so anyway, there's an average calculator, right? This is a task, calculating the average of a list that I have now outsourced to a function, right? So I can just reach up and grab it anytime I feel like. Okay, so let's go back. I think I have one more example to think about. Yeah, prime number checker. This again is something we have done before. So we have already thought about how you take a number like 7, 8, 45, whatever, and decide whether or not that number is prime. So again, prime just means your only divisors are 1 and yourself, right? 7 is prime because only 1 and 7 divide 7, whereas 8 is not prime because 4 is a divisor of 8, as is 2, you know. Okay, anyway, so let's write a function that accepts the number n and decides whether or not the number is prime. So this example I wanted to show you for a couple of reasons, but before I really spell those out, let me go to the compiler and look at that. Okay. I'm going to define a function. This function is kind of different from the previous two, right? Because this one, this average calculator, and this factorial calculator, they're calculating numbers for you, right? So given a 6, this thing needs to calculate 6 times 5 times 4 times 3 times 2 times 1, right? It's calculating a number. As is this function here, this average function. You hand it something, it calculates a number. Okay, this prime number determining thing, right? It's not calculating a number, right? This prime number thing, how do we phrase it? Decides whether or not the number is prime, right? So it's giving you a decision. Like you're asking it, is this prime or not prime, right? And the answer is either sort of yes or no, or perhaps true or false, right? So this function is going to be a little different in that what it's going to tell you or calculate for you is not a number. It's not going to print anything for you, whatever. It needs to determine, given a number n, if the following statement is true or false, right? Here's a statement, n is prime. This function has to decide if that statement is true or false. So it's kind of a different animal, this function. So let me just show you how it works. So I'm calling this is prime. And notice the return statements here. This function doesn't return numbers. It returns either the Boolean value false or the Boolean value true. So let's just walk through how this works. I'm going to let k range from 2 all the way up to n minus 1. So again, recall, you actually don't make your way up to n here. You stop one before. So k is going to start at 2. K is going to go to 3, then to 4, then to 5. And then if n is 8, let's say, you're going to stop at 7, at most 7. Okay, so 7 is as far as you can go if n is 8. And then if n percentage k is 0, I just grabbed this if structure from the previous video where we dealt with prime number checking. Okay, but what's happening here, recall, is that I'm taking n, I'm dividing by k, and seeing if the remainder is 0 or not. So n percentage k is 0. That happens if and only if k is a divisor of n. So again, just as an example, if n is 8, then k will start at 2. Well, 8 divided by 2 is 4 with 0 remainder, right? 8 divided by 2 works out. So since it works out, notice what happens here. This says return false. Why would you want to return false? Well, because you found a divisor. And if you're going to be prime, you can't have a divisor like this, right? Prime numbers don't have these divisors in these ranges, right? By definition. So the statement is prime, that statement will be false, right? If somebody says to you, 8 is prime, they are telling you something false. And you know it's false because 2 is a divisor of 8. Okay, so that's the basic idea of how this function is working. It's the same idea we had before. Notice though, I just say return false, and then there's still more stuff here. Just one more line, but it seems like I'm contradicting myself, right? I'm going to return false and then return true later. After this for loop is done running, I'm just going to return true. That's what appears to be happening, right? I'm going to run this for loop, and when that for loop is done, I'm going to return true. So again, it appears that I have set up a function that will give you back true no matter what the input is. Okay, so the first takeaway from this function is that you can return true or false. Those are actually things that your function can calculate for you. The second thing I want you to notice from this function is, I'm just going to tell you this now, anytime a function encounters a return statement, the function just returns that thing and then stops. So if a function comes across this statement, it doesn't matter how much other stuff you've written here, right? This function could have hundreds of more lines to it. It will just stop. So a return statement inside of a function is much like a break statement inside of a loop. If you encounter a break statement inside of a loop, the loop just stops right then. Right? It doesn't matter what comes after the break statement. For a function, if you encounter a return statement, the function just returns that thing and then stops. So all that to say, suppose you feed in 7 right here, right? Then k will start at 2. 2 is not a divisor of 7. Then k will become 3, not a divisor of 7. 4, not a divisor of 7. 5, not a divisor of 7. 6, not a divisor of 7. So since 2 through 6, none of those are divisors, I'm never doing this. I never go into that if statement, right? Because to go into this if statement, you must have found a divisor. So this for loop runs, and I never found a divisor. Well, if I never found a divisor, then that number must have been prime, right? So the statement 7 is prime is actually true. So the way this function works is it sets up a for loop so that if you're not prime, I'll find out inside that for loop, and I'll return that information to you. But if I make it through this for loop unscathed, then I must have been prime. I'll return true. So down here in main, I can say, okay, let me just put a value here. A is 8. So let's set up something like this. If is prime A. If that's true, tell me, right? Tell me that number A is prime. Else, tell me it's not prime. So if this statement, right, the statement A is prime, if that statement is true, then I should print prime, otherwise I'll print not prime. It printed not prime, right? Why is that? Well, because when I fed in 8, I got an immediate divisor hit, right, of 2. 2 is the divisor of 8, so I returned false. So you feed in A, if A is 8, the return value you get is false, which throws you into this else, right? It's not true. But if I feed in a number like 11, it tells me prime over here. It knows 11 is prime. Why is that? Because this for loop ran and I never once encountered a divisor, right? I never once encountered this return statement. So after all that, I return true. Okay, so again, this is a function where we already sort of had this code up and running before. We just hadn't segmented it out as a function. But if you're a number theorist, say, writing a calculator dealing with prime numbers or something, right? Checking whether or not a number is prime is a task you have to do lots and lots of times. And you wouldn't want to set up this kind of structure inside your code just thousands of times, right? Copying and pasting this code all over the place. Once you write this code once as a function, you can just reach up and grab it anytime you need to determine if a number is prime or not. Okay, so far, all the programs we've written, like here's a program, that include functions, have had a single function, right? Here's a function up here, and then we do a little tiny bit of stuff. Here's a function up here, we do a tiny bit of stuff, right? Function up here, a tiny bit of stuff. In practice, if you're building a very large program, like say the Scrabble program we thought about last time, you're going to have lots and lots and lots of tasks you'll need done. And for every one of those tasks, you'll write a function to do it. So your program will actually start with def function blah, right? And then another one, function 2, and it does whatever it does, right? And then function 3, you're just gonna have all these tasks, right? So you'll write all these tasks up front, and then the rest of the code that uses the functions will come down here below. So we're not going to do that in this video. I just want to give you an idea of where we're going, right? So eventually, once we write these bigger programs, your task will be to think about all the individual little subprograms or little subroutines you need, write them up here so that the actual sort of main part of the program, where you just sort of run things, is very clean, very readable, right? I mean, if you just read this, it's pretty clear what I want to have happen and what's going on, right? And in fact, you can read this down here without reading anything above and still figure out what I've done, right? You can figure out, oh, like he must have written a function that determines if something's prime or not, right? Because that's how the structure is set up. So anyway, so that's an idea of where we are headed. So let me just conclude with a couple of comments here. This prime number checker function, I want you to take away two things from it. A function can actually give you things back besides numbers. It doesn't have to calculate a number for you. This function in particular returns either true or false. The calculation performed by this function is not a calculation of a number. It's a decider of true or false. The other thing to take away from this is that if a function ever reaches a return statement, the function just stops. It returns what you tell it to return and it stops. So a return statement in a function behaves much like a break statement in a loop. Okay, so hopefully after this video you are slightly more comfortable with functions, at least more comfortable than you were at the end of the last video.